Hey guys, welcome back to SudokuManiacs. I'm sorry I was absent for a couple of days, but things have been hectic here. I mean, the place where I live, there are about 900 apartments, and last week we had a few COVID cases coming out positive here. So there's been a hectic and a lockdown kind of scenario here. And unfortunately, or fortunately, I am one of the members in the emergency response team for these apartments. So we kind of have to take care of the stuff for people, make sure nobody else goes near the contaminated places, near around the house and take care of stuff. So it has been a bit hectic. Found some time today, so I thought why not quickly create a video. And today I just thought that why don't I present a puzzle that I was creating a couple of days back. Now I was in the process of creating a hybrid puzzle for my website, and in a way it turned out a bit tough. It wasn't very straightforward as it normally puzzles are expected to be. I mean, some might even find it to be on the hard difficulty level as well. So I thought, okay, I want to put it out for the general public because I don't want people just leaving it halfway and going. So I kind of kept it free on my blog and shared it with the groups and friends. I will be sharing the link to solve it online, obviously, in the description. But I know for sure a lot of people will have questions. So I thought, why not create a walkthrough on this? And it turned out beautiful, if I may say so, because the 2016 World Champ Teach One did have some glowing words for it. He found it to be an excellent, excellent puzzle. So I'm presenting it for you guys. I hope you guys enjoy it as much as Teach did. And yeah, to make sure you don't miss out on these interesting puzzles, I hope you guys are subscribed to the channel and the bell icon has been clicked so that you do continue to receive the notifications. Now the hybrid puzzle that we are going to solve today is basically an anti-knight Sudoku, that is no digit can repeat at a knight step from itself. And there are certain cells which are marked by circles and squares. So basically circles can contain only odd digits and the squares can contain only even digits. And rest of the squares can have either. So without wasting much time, why don't we jump into the puzzle? Alright, so the first thing I see is in box 7 I got a 2 and a 4, which means these can only be a 6 and an 8. Oops, where did the pencil marks go? Yeah. And I have a 1, 3, 5, so means these circles have to be 7 and a 9. Right, so this 9 here, this is a 7, that's my 9. This is a 6 here, so I have the 3 odd numbers available with 2 circles. So obviously these will have to be 1 and 5, right? And I get 2, 4, 6, 8. This would be 2, 4, 6, 8, 2, 4, 6, and 2, 4, 6, 8. So I get that. Even, even with the 8 given. So again, this would be 2, 4, 6, 2, 4, 6. So the rest of the digits have to be odd. So this will be 3, 5, 9, 3, 5, 9, 3, 5, 9. As I said, this will take some time because it's not so straightforward. But again, we have a 3. Let's not forget the anti-knight rule. So this cannot be a 3. So this will be a 5 and a 9. And this cannot be a 9 because we already got a 9. With this 9 here, 9 cannot be here. 9 is logged in these two. Okay. What next? Yes. So this will be a 3, 7. So the next step, now the tricky part here is this is a 3, 7 and this will be one of these three, right? Which basically means in box 8, whichever number is here will be logged in these two. Am I correct? But this cell is at a knight step here. So this cannot be the same number. So this, if it was marked by an X, would have to come here. So this also will be a 3 and a 7. And this also being an even number with a square will be 2, 4, 6, 8. So I got 4 evens, right? Which means all these are odd numbers. 1, 3, 5, 7, 1, 3, 5, 7, right? Now, the reason I'm placing this 3, 7 is because if this is a 3, this can still be a 7. It's not necessary that both 3 and 7 will be eliminated from here, right? What next? 8, 8, 8 will be part of these two. 9 is not here. It's not here, so 9 has to be 1 here. So if these two are 9, for box 2, 9 cannot be here because of the 9th step, so this becomes my 9. Right? So with this 9 gone, this can't be a 9, this can't be a 9 because of this, and by classic rules, I have a 9 here. The 4 cannot be here with the square, so this will be 2, 6, and 8. Da, 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 da. Okay, this is also 2, 4, 6, 2, 4, 6, which makes this 3, 5, 7, 3, 5, 7, 3, 5, 7. A lot of pencil marks will be there, don't you worry about that. Okay, this was a 1. This is a night step, right? So that becomes my 5, and that's my 1, so I can eliminate the 1 from there. And this 1 cannot be here, this is an even number. So that is my 1, right? 1, 1, this can't be a 1. So the 1 is logged in row 4 and row 5. And if we remember the old technique, when I have two adjacent numbers, at a distance of 2, I cannot have 1 here. This cannot be a 1. This cannot be a 1. So my 1 is locked up in these. Right? Got this? How we eliminate it? Because if this is a 1, this will be in the same row and this will be at a night step. And if this is a 1, this is in the same row and this would be at a night step. So we can't have 1 then. So these are the only two places left for 1 because this is at a night step here. Now when I look at this, these two share a relationship with the 1 at row 5, column 7. Because if this is a 1, it's in the same row. And if this is a 1, it would be at a night step. So I can safely eliminate the 1 from there. And I get a 1 here. Right? So these two are 1. 1 cannot be in this. 1 cannot be here. This is square. So these would be 1s here. This is not a 1. So 1, 1. Oh, this is an even number. So obviously I can eliminate these 1s. Get a 1 here and a 1 here. This can be removed. This 1 is at a night step, so that's my 1. And I get a 1 and we wrap up the 1s. Good so far? Now 9s. Let's look at the 9s. This is the 9, this is the 9. This is an even number. This is at a night step, so I get my 9 here, which makes this a 5. That's my 3, and that's my 9. I can eliminate it. Now 9, 9, 9. This is at a night step. This is at a night step. That's my next 9. And I get all the 9s as well. Right? Hmm. 7 can't be here. So my 7 is locked in this. And by classic rule, 7 can't be in these. These two are even numbers. So my 7 is locked up here. Again, if the 7 are two adjacent cells, so at a distance of 2, I can eliminate, I can eliminate the 7 from there, and this would be my 3, 5. 7, 7. So 7 has to be in these two. And again, if you remember, when we had two alternate cells with a 7, this cannot be a 7 because this cell is at the same row or same column as well as at a night step here. So I can again eliminate the 7 from there, this becomes a 3 5. Right? Now what would this be? This would be a 2 6 because I got a 4 here, that's an 8. This again would be a 3 5 7. So now this is a 2. By classic rules, the 2 and 8 have to be in these four, right? But these are odd numbers, so this becomes my pair of 2 and 8, right? Which means the 4 and 6 will be logged in these along with the 7 here. So with 2, 4, 6 and 8 gone, this also has to be an odd number. So this is again a 3, 5, 7. That gives me a triplet here. So this also has to be 2, 4, 6. Right? What next? So if this is a 3, 5, that cannot be here. This is not 5, 1, 5. So this is a 2, 8. This is a 2, 4, 6, 8. 2, 4, 6, 8. And this also will be 2, 4, 6, 8 because I can't have any. So 1, 2, 3, 4. So obviously this cannot be a 4, 6, but I can have a 3 and a 5 here. So this is a pair of 4, 6 here because for row 6, I have all the 4 even numbers located. This 5 cannot be there, so that's a 3, 7 and a 3, 7. So if this is a 3, 7, again I cannot have either of these numbers here. Because if this is a 3, the 3 is in the same column and the 7 would be at a night step. If this is a 7, the 7 would be in the same column and 3 would be at a night step. So that becomes my 5. I can eliminate that. I get a pair of 3, 7 here. So if that's a 5, this becomes my 5 because I have a 3, 7 pair, 1, 9 here. I can eliminate that. So that's a 3, 7. That's a 3, 7 and this becomes a 5. So we have another pair. Now let's see the 5 here, 5 here. 5 is logged in these two. 5 cannot be here. 5 cannot be here. And by classic rules, the central number has to be a 5. 5, 5. The 5 is in these two, right? But this 5 is at a night step. So the 5 has to be here. And this becomes a 5. This again is a 2, 4, 6. So we slowly and steadily 3, 3. So that's my 3. And we're slowly wrapping up all the odd numbers. That's a 7. 3 is not here. It can't be here because of this. So that's my 7. And that's a 3. 3 cannot be here. So this is the only place left for 3. And that's a 3. And the last 7, 7. That's my 7. And that's a 7. So that becomes a 7. And we have managed to put in all, what do you say, the odd numbers. Good, good. So now the 4 of box 1 is logged in color rows 1 and 2, right? Which means this cannot be a 4. The same rule. So this is my 2, 6. This 2, 6 would be the same as this one because if let's denote it by x. If that's an x, it's in the same row as this and a night step at this. So the x will have to come here. And for classic rules, this is an x, this is an x. X would have to come here. So that eliminates the 4 and I get a 2, 4, 6 here. Right? The 8. Let's look at these two cells. These are both 2 and 8, right? How do we use that to eliminate? Let's have a look at this cell. Now the row 6 column 4 cell shares the row with this 2, 8 and is at a night step at this one. So irrespective of where the 2 and 8 come, both those digits cannot repeat here. Because if this was a 2, 2 is eliminated from here and this 8 gets eliminated because of the night step. So we get a pencil mark of 4, 6, right? And this 2, 4, 6 will be here. 4, 6, 2, 4, 6. Now this could also be an 8. But how do we eliminate the 8 from here? That's the question. The point here is, if this was an X, right? It cannot be here. It cannot be in these two cells because both are at night step to this 2, 4, 6. Hence, whichever number comes here has to be in this cell, right? Hence, the 8 gets eliminated. We have 8, 8, and that's an 8. And with the 8 here, it cannot be here at a night step. So this becomes an 8. That's my 2. That's an 8. 8, 8. That's my 8. 8 is eliminated. 8 is in these two cells. That's an 8, 8. So this is my 8. That's a 8. Again, this gate 8. So, sorry, that's an 8. That's my 6. So that becomes a 2. And these 4, 6 means this has to be a 2, 2. Right? So this 2 cannot be here. That's a 4, 6, 4, 6, 4, 6. Where will this 2 be? The 2 is logged in these two, right? So this cannot be a 2 because one cell shares the column, the other one is at a night step. So I have a 4, 6, I have a 4, 6. That becomes a pair. That gives me a 2 here. So 2 is logged in these two. 2 cannot be in these two because of this. So that's my 2. That's a 4, 6. So the 4, 6. So that's a 4, that's a 6. Now this is at a night step. 4. And that's a 2 and a 6 because we got a 2 here. So that's a 4, that's a 6. Sorry, 6 and 4. 6, 4. 6, 4. 6, 4. 6, 4. We got a 4, 4 and a 6. Well, I think we did manage to solve it. I I know it's my puzzle, so I can't gloat too much over it. But somehow, I love the way the constraints played a big part in getting this to the solution of this. Hope you enjoyed the puzzle and the video. If you did, do like and subscribe to the channel. And what I would suggest is, I want you to try out the puzzle first, and then refer to the video, only to find where you're stuck and what the next step forward would be. So, I'll see you guys tomorrow. Until the next time, happy solving!